Here are the graphs of three straight lines and their associated equations. You can see that all of these equations fit with our idea that the equation of a straight line is of the form y equals mx plus c. Remember, in this, m is the gradient. If we look at all of these, we can see that they all have the same gradient, which is 2. Now, if we actually look at the lines, we can see that they're all parallel, and that's because they all have the same gradient. Here's a quick question for you to try now. Which of these two lines are parallel? Press pause and have a go. When you're ready, press play. Here's the answer. Lines 2 and 3 are parallel because they both have a gradient of 3. Now in this question, I'm being asked to work out the equation of the line that passes through this point and that's parallel to this line here. Remember, the equation of a line is always y equals mx plus c. Now because it's going to be parallel to this line, I know the gradient is going to be 2. So I can now write y equals 2x plus c. Now to find y and x, I can look here. I've got an x-coordinate of 2 and a y-coordinate of 5, so I can put those into this equation. So remember, the y-coordinate was 5, the x-coordinate was 2, and I still don't know what c is, but now I can solve this to find c. I've got 5 equals 2 times 2, which is 4, plus c. So looking at this now, I can see that c must be 1. So the equation is y equals 2x plus that c, which is 1. So we've got y equals 2x plus 1. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. So remember, the equation of a straight line is y equals mx plus c. It's going to be parallel to this, so m is 3, so we've got y equals 3x plus c. Now y is minus 3, and x is 1. We can solve this to find c, so we've got minus 3 equals 3 plus c, so c must be minus 6. So we have y equals 3x minus 6. This question looks a little different. I want to find the equation of the line which passes through the point B here and that is parallel to the line AC. I know it's going to be y equals mx plus c. Now I need a gradient, so I'm going to have to look at the gradient of this line. To do that, I find the point where it crosses the y-axis, go 1 to the right, and then go up until I meet my line. I've gone up by 4, so the gradient must be 4. So I've got y equals 4x plus c. Now the coordinates of point B are 2, 1. So y is 1 and x is 2. So I've now got 1 equals 8 plus c, and I can work out from this line that c is minus 7. So the equation is going to be y equals 4x minus 7. Here's one of those for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Take care when you're finding the gradient of the line this time. Press pause and have a go. When you're ready, press play. Here's the answer. This question looks slightly different. I'm being asked to find the equation of the line which passes through points A and B. Before I start trying to find this equation, I'm just going to draw the line on. I know that the equation of the line will be in the form y equals mx plus c. Just like before, once I know the gradient of the line, I can put it in here and then use either one of my 2 points to help me find c. The only difficult bit is finding the gradient of the line, because I haven't got a grid here to help me do that. So how do I find the gradient of this line here? We know that the gradient of a line is given by a vertical distance divided by a horizontal distance. Up until now, I've always used a horizontal distance of 1, but because I don't have a grid this time, it's more difficult to do that. So what I'm going to do is use any 2 points. I want to find the vertical distance here. Now this vertical distance will be the difference between the y coordinates. So it will be this one here, which I'm calling y2, minus this one here, which I'm calling y1, and that will be the vertical distance. The horizontal distance works in the same way, but with the x coordinates. So this will be x2 minus x1. So now we have a new formula for our gradient. It's the vertical distance, that's y2 minus y1, divided by the horizontal distance, that's x2 minus x1. This is a really important formula which you'll be using a lot because it allows you to work out the gradient of any line if you know 2 points on that line. So back to our question now, armed with our new formula. Let's say that this one is x1, y1, and this one is x2, y2. Now to find the gradient, I've got y2 minus y1, so that's 1 minus minus 4, divided by x2 minus x1, so that's 6 minus minus 4. So that's 1 plus 4, which is 5, over 6 plus 4, which is 10. And 5 over 10 is actually a half. So I know now that the gradient of this line is a half, so I can put that into here. I've got y equals a half x plus c. Now to find the c, I just need to put in either one of these 2 points into this equation. I'm going to use point B because I don't really want to work with negatives. So on point B, I can see that x is 6 and y is 1. So y is 1, x is 6, and I've still got plus c, but now I can use this to find c. I've got 1 equals 3 plus c, so c must be minus 2. Combining this with this, I've now got the equation of this line. It's y equals a half x minus 2. Here's one for you to try now. Press pause and have a go. When you're ready, press play. So we want to find the equation of the line joining A and B. Let's start by drawing that line. Now we want to find the gradient of it. So remember, the gradient is y2 minus y1 over x2 minus x1. So I'm going to say that this is x1, y1, and this is x2, y2. So y2 is 9, minus y1 is minus 6. x2 is 2, minus x1, which is minus 1. So I have 9 plus 6, which is 15, divided by 2 plus 1, which is 3. So that's 5. So I know now that the gradient is 5. So my equation will be y equals mx plus c, but I know that m is 5. To find c, I can use either of these 2 points, but I'm going to go for this one to avoid the negatives again. So y is 9, x is 2, and we've got plus c. So 9 equals 10 plus c, so c must be minus 1. Now I have the equation, it's y equals 5x minus 1. Just out of interest, one of the most common questions that people ask is which one's x1, y1 and which one's x2, y2. The answer is it doesn't actually matter. If I'd have said that this one was x1, y1 and this was x2, y2, watch what happens with the gradient. I know that it's y2, that's minus 6, minus y1, that's 9, over x2, that's minus 1, minus x1, that's 2. Now minus 6 minus 9 is minus 15, and minus 1 minus 2 is minus 3. It looks like it's coming out different to this, but minus 15 divided by minus 3 is still 5, so we still have the same gradient. So it doesn't matter which one is x1, y1 and which one is x2, y2. Here are 2 more questions for you to try. The only difference this time is that there's no diagram to help you. If you feel that you need one, you can always sketch one yourself. Press pause and have a go. When you're ready, press play. Here are the answers.